Welcome to integration by parts. This is another method we can use to integrate certain functions. In the integration by parts, the rule is derived from the product rule. Okay, and there's a couple ways to write this. We have the differential rule. We have the differential rule here, and that's more common to use. I don't use that one. I think it's easier to use this method down here. We'll talk about that. But what we're saying is that the integration of u dv is equal to u times v minus the integral of v times du. Now, u and v are functions, and dv is equal to v prime of x, and du is equal to u prime of x. So, alternatively, we can use the integral of u of x times v prime of x dx. That's equal to u of x times v of x minus the integral of u prime of x times v of x dx. Now that's a lot of things going on. But remember, the key here is to figure out what u and what v prime are going to be. So really the whole goal is to look at these two functions first. What's going to be u, what's going to be v, and then we follow this pattern. Okay, the best way to demonstrate this rule is just through example. And that's what we're going to look at. So again, the key to using this integration by parts is you'll probably have two functions being multiplied together, and we'll see an example where that's not necessarily true, but for the most part you'll see that. So let's take a look at an example. In problem 1, we're going to evaluate the integral of x times cosine of x dx. Okay, so then again we have two functions being multiplied together. So the solution here is we've got to pick u and we've got to pick v prime of x. So let's just pick. So I let, in this case, u of x be x and let v prime of x be cosine of x. Now, how do you know if you pick the right u and the right v? Well, as you get through the problem, as you continue to move forward, you should be getting an integral that's simpler to deal with, not an integral that is more complicated. And you'll see that in problem 2, where I show you what if we accidentally go and pick the wrong u. Okay? So u of x equals x, v prime of x equals cosine of x. So let's write the integral. So here's what we started with. So here is the integral of x times cosine of x dx. That's what we're actually evaluating, so this doesn't change. Now notice here I wrote u of x equals x, v prime equals cosine of x dx. So again, this is going to equal the integral of u of x times v prime of x dx. So let's go ahead and apply our integration by parts. Well, we know u of x is x. This implies u prime of x equals 1. Well, the derivative of x is 1. So now notice here my arrow's going the other way because I've been given v prime of x, okay, is equal to cosine of x. So I have to go in reverse. Okay, so if I know the derivative to get the original is the antiderivative. So cosine of x is sine of x here. Okay, so we've applied our integration and now we've got to simplify and substitute. So let's look at what's going on. I rewrote the alternative method up here and I try to use different color. I use different color markers. So again, here's the original. This whole part is the original. It is equal to u of x times v of x minus the integral of u prime of x, v of x dx. So let's look at what we have. We know that u of x was x, v prime of x was cosine. So there's the original problem. All right here is original. Here's where the integration by parts takes place. We have u of x, which is x, v of x, which was sine, okay, minus the integral of 1, which is u prime of x, times v of x again, which was sine x dx. So this portion is done. So if we look down here, x sine of x is right here, and right here in the final answer. But we have to subtract off. We have to subtract off this integration. Okay? So what we have to do is now is integrate really sine of x, which is negative cosine of x. Okay? So when we simplify, we have x sine of x minus the opposite, or minus cosine of x plus c. So this becomes addition here. Okay? So x sine of x plus cosine of x plus c That's our final result. So when do we choose U? What do we choose for U? What do we choose for V? You want to choose U so that U prime is simpler than U itself. And you want to choose V prime so that you can actually take the integral of V prime of dx. So you can anti-differentiate. So those are the two big keys. What you pick for U, what do I pick for V? So let's look at problem number 2. Evaluate x e to the x dx. So in this case, I'm going to let U equal x because the derivative is 1. Well, that's simpler than x, so that's pretty good. V prime is going to be e to the x, and I know I can evaluate the integral of e to the x dx. So I've kept these two things in check. I've followed these two general rules. Okay, so let's look at the integral. We're going to do our integration by parts, and again, I wrote the entire rule for you. So here again is the original problem right there. So here, x e to the x, we should have a dx there. So that's equal to u of x times v of x minus the integral of u prime of x times v of x again. So again, when we take v prime of x being e to the x, we know the antiderivative of v prime of x is going to be itself. Okay, the antiderivative of e to the x, so this remains the same. So u of x is x, v of x is e to the x minus the integral of 1 times e to the x dx. We're not done because we have to integrate e to the x, which again is just e to the x plus c. So the only thing that changed was in red. Our subtraction sign comes down, okay, and here is our final answer. So the idea here is, what if I switched u and I switched v prime? Let's just say I let u be e to the x and v prime be x. Let's see what happens. Okay, so u prime of x equals e to the x. Okay, so if u of x equals e to the x, we know the derivative is also e to the x. V of x, we're going to actually look at having to integrate x d to the x, which is this, right? When we integrate x, it should be x squared over 2, and we can just rewrite that as 1/2 x squared plus c. So let's apply our rule. Here's our original function. Okay, here is u times v of x, okay, right here, minus the integral of u of x times v prime of x. Okay, so we put that all together, and notice I could integrate this, but it's more complicated. What I boxed in red is a lot more complicated. It's not necessarily wrong, but since it's more complicated, I know I've chosen the wrong u and the wrong v. So you just have to be very careful on how you pick your u and v. In general, you pick u, that's going to be simpler when you take the derivative, and you pick a v prime of x that you can actually integrate. Okay, that's it for integration by parts for now. Stay tuned for the second video lecture on this, where we get into a few more complicated examples. If you have any questions, just email me or type in the comment box below. Thanks, guys.